Representation of decimal numbers on number line. Now on this number line we can see the whole numbers. In a similar way, even decimal numbers can be represented on a number line. For that, consider 5.1. This is a decimal number and here 5 is the whole number part. On the number line, first locate 5 and the unit between 5 and its successor. Successor means 5 plus 1, 6. So the distance between these two has to be divided into 10 equal parts. We'll mark this and each and every marking should be given a value. The first one represents 1 out of 10, second one is 2 out of 10. In the same way, the last one would be 9 out of 10. These are in fraction form and the same can be written in a decimal form. In decimal form, we can write it as 0. That give values for each and every marking. Here we can see the marking 0.1. 5.1 is nothing but 5 plus 0.1. So after 5, the 0.1 gives the location for 5.1 on the number line. We'll see how to represent 6.4 now. The first step would be to locate the whole number on the number line, that is locate 6 and its successor 7. The unit between these two things, divide that into 10 equal parts and give value for each and every marking. Now here we can see 0.4. So this 0.4 comes after 6. So this is location for 6.4. Consider 0.8 now. First thing is to locate whole number 0, then and its successor 1. We'll divide this unit into 10 parts and give value for each and every marking. Here we can directly locate 0.8. To represent 3.25, here we have till 100th place. The first step would be to locate the whole number part, then 10th part, and then we will locate the hundredths part. So 3 is a whole number, its successor 4, divide that into 10 parts, give the markings for each and every part. The second marking is for 3.2. Now 3.2 and its successor is 3.3. Now the distance between these two numbers 3.2 and 3.3 has to be divided into 10 equal parts. Now here if we locate the 5, that will be the location for 3.25. So we'll count these marking here. This is 1, 2, 3, 4, 5. So this particular marking here would be for 3.25. Now we'll see how to represent 9.76 on the number line. First, locate the whole number part, that is 9 and its successor. So we have located 9 to 10 on the number line. This portion has to be divided into 10 equal parts. Mark each and everything here. So the 10th location is for 7. We have to locate 0.7 on this number line now. So this value is for 9.7. 9.7 and its successor 9.8. This portion has to be divided into 10 parts again. And then here count the sixth one. So 1, 2, 3, 4, 5, 6. This sixth one is for 9.76. Now we'll see how to identify the locations on the number line. Here we have A, B, C, D, 4 different points. We have to write the values for each and every point. Consider the point A, it's located here. So if we count, this is for point 1, point 2, point 3, point 4, point 5, point 6, point 7 and this is then point 8. So A gives the location for point 8. Now B is located on this marking. So this is 1, 2, 3 means 0.3. 0.3 after 1, which means 1 plus 0.3, or directly you can write it as 1.3. So 1.3 is the location for point B. Now consider C. The first one is for point 1 and then for 0.2. So C location is, it is after 2. The whole value is 2. then point 2. Location for D, so if you write on like this, the last one would be 0.9. So it is after 2, 0.9. So 2 as a whole number, point 0.9 is the location for point D. Comparing decimals, we'll see how to compare decimals. For this, we'll have two values and each and every decimal number. First compare the whole part and then tens place, then hundreds. Now consider 1 and 0.99. 1 means 1.0. To compare these two, first consider the whole part. In this, 1 is the whole part and here 0. 1 is greater than 0, so 1.0 would be greater among these two. We'll compare two more decimals, 1.09 and 1.093. First compare the whole number part, 1 here and again it's 1. They are same, so consider the tens place. So this is tens place and again this is tens place. 0 in both the numbers, same. So now compare the hundreds place. So hundreds place is this and here this is the hundreds place. Again it is 9 in both the numbers. So till hundredth place both have same. But for the second number we have the thousandth place as well. So this one would be greater. We'll consider more numbers. Take 0.3 and 0.4. Whole number part is same. In tens place it is 3 here and 4. 4 is greater than 3. So 0.4 would be greater. Now consider 0.07 and 0.02. Till tens place it is same in both numbers. In hundredth place 7 in first number and 2 in the second one. 7 is greater than 2, so 0.07 would be greater. Compare between 0.08 and 3. Whole number is 3 here and here the whole number part is 0. 3 is greater than 0, so 3 is greater among these two. Now compare 0.5 and 0.05. Whole number part is 0 in both the numbers. So comparing the 10th position, here 5 in one number and 0 in other one. 5 is greater than 0, so 0.5 would be greater. 1.23 and 1.2. Here till 10th place they are same. But in one of these numbers we have hundredth place as well. So the one which has got the extra digit, that is the first one, 1.23 would be greater. Now 1.431, 1.491. Consider the whole number part, both are same. 10th position, same for both. And the hundredth position, here it is 3 and here it is 9. 9 is greater than 3, so 1.491 would be greater. We'll consider 5.64 and 5.603. Whole number part is same. Value in tenth position is same. Value in hundredth position is 4 here and here it is 0. 4 is greater than 0. So 5.64 would be greater among the two. Now where are we going to use these decimals? We can use them in concepts of money, length and weight. We'll see for money. In money we know that consider rupees. 1 rupee is equal to 100 paise. Means 1 rupee has got divided into 100 units. So when we say 1 paise, it is nothing but we are considering 1 out of 100 parts of a rupee. So 1 paise would be equal to 1 upon 100 rupees. Or this 1 upon 100, how can we write this? 0 point, we are going to convert this fraction into a decimal number. Here we don't have any whole number, so it is 0 point. The value for tenths place is 0 and in hundreds place we have to write 1. So 1 paise will be equal to 0.01 rupees. Now if we want to make more conversions, consider 50 paise. 50 paise is nothing but 50 out of 100 parts of a rupee. Now, how to write this into decimal number? We divide both numerator and denominator with 10. 50 divided by 10 means 5, and in denominator 100 divided by 10 means 10. 5 upon 10 rupees, or as a decimal number 0 point in 10th place we have to write 5. 0.5 rupees. Now similarly consider 65 paise. How to write 65 paise in terms of rupees? 65 out of 100 parts of a rupee. Now 65 can be written as 60 plus 5 upon 100, which is nothing but 60 upon 100 plus 5 upon 100. Now, both the numerator and denominator for this fraction, if we divide it with 10, it will become 6 upon 10 plus 5 upon 100. So, this is 10th place, this is 100th place. So, 0 point in 10th place 6, in 100th place we'll write 5. 0.65 rupees. Now consider uses of decimals in length. While measuring length, we know 1 meter equal to 100 centimeters, or we can write 1 centimeter is nothing but 1 out of 100 parts of a meter. So this is 1 upon 100. In 100th place, we have to write 1. So 100th place means after dot we will have 10th place. There we don't have any value. Then in 100th place we'll write 1. 1 centimeter is equal to 0.01 meters. 45 centimeters in terms of meters, which means 45 out of 100 parts of a meter. Now 45 upon 100. This we can directly write. We have discussed this in the previous videos. To write this, when we have two zeros in the denominator and we have two digits in the numerator, we can directly write it as 0 point, both the values from the numerator, 0.45 meters. Now let us consider 64 centimeters. So this is nothing but 64 upon 100 meters. Either we will directly use this like two zeros here and two digits here. Directly we can write this, or consider converting them into place values. In that case, we should have only one digit in the numerator. For that, what we have to do, we'll 64 as 60 plus 4, and then we'll separate these two things plus 4 by 100. Now 60 upon 100 will become 6 upon 10, and the second one is 4 upon 100. So if we want to write using the place value in the 10th place and in the 100th place, we have to see that it has got only one digit in the numerator. So only one digit in the numerator. In the 10th place, we have to write this. So 6 in the 100th place, we have to write 4. 0.64 meters. Now say we have 150 meters. So which means 150 out of 100 parts of a meter. How to write this now? 150 plus 100 plus 50 upon 100. The first one 100 upon 100 plus 50 upon 100. 100 upon 100 is 1 plus 50 upon 100. Now again, if we divide both numerator and denominator with 10 here, this becomes 1 plus 5 upon 10. So 1 is a whole number part. We'll write in whole number dot, and in 10th place we have to write 5. the dot we will write 5. 1.5 meters. Like this we can use the conversions for length. Now consider the weight. 1 kg is equal to 1000 grams. While doing conversions here, consider 350 grams. 350 grams, if you have to convert this into kg, 350 out of 1000 parts of a kg. So both numerator and denominator divide with 10 and write numerator will become 35 upon denominator 100. So this is nothing but 0.35 kg. Consider another value 225 grams. This is nothing but 225 out of 1000 parts of a kilogram. So we have three zeros here and three digits separately in the numerator, which means 0.225 kg. Consider 50 grams now. So it is nothing but 50 upon 1000 kg. So here we have three zeros but only two digits. In that case, we'll write a zero towards left of the number. We know when we write zero towards the left of any whole number, the value doesn't change. Keep 0 point and write the numerator